Okay, everybody, a little bit of a recap. Everybody say hi to Finna. Finna's hanging with me. So here's what we did, 920. And so we went back to the problem that was our extra credit. It's kind of a complicated design, but we kind of put it together that we knew we counted the white tiles. So on design 1, we counted the white tiles was 12. We counted the green tiles were 13, and we counted the total tiles. We just count them up. We got 25. Then we designed 2. We counted up the white tiles. There was 40. We counted up the green tiles. There was 41, and the total tiles was 81. So then we designed 3. All right, we counted up the white tiles. It took a while to count because there's a lot of them. 84. Then we counted the green tiles. Counted them up. There's 85, and the total tiles was 169. Okay, I think it was 13 by 13. So they go, wait a minute, this is crazy. I don't want to keep doing this. I don't want to keep counting them and make it, so there's got to be a formula. So I said, okay, well, if there's a formula, it's going to make this job much easier for me. So, all right, so I thought about, okay, well, what did I think about? Hold on. Why is this chair broken? Oh, here we go. So I thought, okay, now I've got to come up with a pattern. So I went white tiles. Let's see, white tiles. If n is 3, then white tiles, let's see, I've got an n, an n. So I've got a 2n plus 1. And it's a rectangle, so I got a 2n plus 1 times an n. So I got a 2n plus 1, and I've got 4 of those rectangles. So it's n times 2n plus 1, and there's 4. So there's a formula. And then I can easily make the 4th one, the 7th one, the 10th one, just by plugging these numbers in my calculator. So I'll show you. Grab a calculator. I'll show you what I'm going to do. So if I wanted to do the 4th one, I'd just take 4, and I'd plug 4 into my formula, right? So, okay, I go, let's see, I'd go 4 times 4 parentheses. I'd go 2 times 4 plus 1. I get 144. And then, of course, I know that the green tiles is 1 more. That's easy. And the total tiles, I can just add those 2 up, okay? So then 7, I do the same thing. I can plug in 7. I can plug in 10. Now the formulas for the rest of these, let's see. Green tiles. Let's see. Let's go back to here. So green tiles has got a n by an n, and there's 4 of those. There's my 4n squared. I've got green tiles. Let's see. For the big square, I've got an n, and I got an n plus 1 times another n plus 1. So I've got a 2n plus 1 squared plus the 4n squared. Okay. Now, the big design has got, let's see, there's an n1, 2 n's, 3 n's, and I think I get 4. 1, 2, 3, 4n plus 1 times another 4n plus 1, and that would be the total tiles, okay? Or I just add these 2 formulas and I should get the same, and that's what the lesson's all about. You're saying, okay, well, what if I do look at the 2 similar formulas and I prove that they are the same? So, and that's what we did. We did the math. We took Tanya's, and we've just simplified Tanya's. Foil it. Add the n squareds. We took Alex's, and we simplified Alex's. Wrote that twice. We multiplied it through, and sure enough, we wound up with the same. So if we go back to our figure, these 2 added together should equal this one, because it's the number of white tiles plus the number of green tiles, okay? And we prove that over here, okay? That we have the sum of the white and green makes the total number of tiles, okay? All right, let me back up then, okay? So, in design 7, how many tiles are in design 7? How many white tiles? Total white tiles, green tiles, and of course total tiles. That was easy. we wanted to design a floor that was 17 total green and white tiles. And I knew that the 10th would give me 1,681, but if I tried 11, it's too much. So we could only build something on the 10th design would work. Okay? All right. Then we just kind of talked about the fact that they're all quadratics because they're x squared. They're all quadratics because they're x squared. They're all quadratic because they're x squared. Okay? And that's all we have. We were able to prove that green tiles are one more white are one more than green. So we took their formulas, we set them equal, and again we were able to show they're the same. Okay. All right. So that's all I have for today. We did a Mathia assignment, but we also have lesson 3 assignment out of the book. Okay. So that's all I have, and I will see everybody tomorrow. It's just so much easier to record after.